Hello, welcome back for lesson 9.4. In this lesson, we are continuing our learning of two sample t-tests, two sample testing, I should say. In this lesson, we're going to be testing the difference between two means, so we still have quantitative data, but they're dependent samples or matched pairs. So remember our intro topic of how to tell between independent and dependent sampling. Matched or paired samples are usually a before or after, or maybe twins that are compared to one another, something like that. So when using a hypothesis test for matched or paired samples, the following characteristics should be present. You should have simple random sampling. Your sample sizes are often going to be small. There's going to be two measurements are drawn from the same pair of individuals or objects. The differences are calculated for those matched pairs, and the differences from the sample is used for the hypothesis test. So essentially, we're creating one sample that we're going to be using, and we're going to be performing basically the t-test that we learned in chapter 8. So we're going to go back to having just a degrees of freedom of n-1 because we're essentially going to have one sample of data. So we're going to have the sample means of our differences, subtracting the population mean difference, which we assume is 0, divided by the standard deviation of the differences, divided by the square root of n. That's our test statistic. And the next page, right now it's page 199. It'll be around that same page, will be the outline of this hypothesis test. The one big difference is that in this test, our H0 and HA or H1 are going to be using just the mean of the differences compared to 0, with a not equal to, less than, or greater than, instead of comparing one sample to another. It's the mean of the differences. So that's the key thing. And then also, even though we have two samples, we end up creating one sample of the differences. So our degrees of freedom is just n-1. So let's go through our first example that I kind of put together for you. It says a study was conducted to investigate the effectiveness of hypnotism in reducing pain. Results for randomly selected subjects are shown in the table. A lower score indicates less pain. The before value is matched to an after value. So they had a pain value before they did their hypnotism, and then a pain value after the hypnotism. So we're hoping that their pain value would go down. It looks like everyone went down in pain value except patient A. So I have decided to calculate after minus before. And so I'm hoping that after minus before is less than 0, because that would indicate the after is less than the before. And so we'd have a negative value difference. And so I put my afters in this column, my befores in this column. I took the difference. The only one that was positive was the patient A. So now we have one sample of data. That's our differences. And we calculated the mean right here. The mean of the differences is a negative 3.13. The standard deviation of the differences is 2.91. Our hypothesis statement is H0 is the mean differences are equal to 0. HA is the mean differences are less than 0. The null hypothesis is 0 or positive, meaning that there is the same or more pain felt after the hypnotism. So we want to see if there is improvement. If there is improvement, then the differences would show a negative value. Our degrees of freedom are n-1, which comes out to be 7. And we are using T of 7 as our critical value is 1.895 critical T. And then our test statistic, I gave it to you there, but I'm going to show you how I calculated that. It's the sample mean of the differences, subtracting 0, divided by the sample standard deviation of the differences, divided by the square root of n. So here is our test statistic. And And so any test statistic that's less than a negative 1.89, our critical t-value, is going to be in the danger zone. And so that danger zone is right here. Remember, there's two ways of looking at it, either, and our test statistic is a negative 1.89. Anything in the danger zone is where we are going to reject, or we can look at the p-value. The p-value is an extreme value, and because we are doing a left tail test, we're testing to see a t less than a negative 3.04 using our test statistic here. And you can see that comes out to be 0.0095, maybe 0.0094. And so when we compare our p-value to the alpha of 0.05, our p-value is less than alpha, so we do reject H0. And I stated that there. And then there's our conclusion. At a 5% level of significance from the sample data, there is sufficient evidence to conclude that the sensory measurements on average are lower after hypnotism. Hypnotism appears to be effective in reducing pain. The next example we're going to work together is example 2. Does a study was conducted to investigate how effective a new diet was in lowering cholesterol. Results for the randomly selected subjects are shown in the table. The differences have a normal distribution. Are the subject's cholesterol levels lower on average after the diet? Test at the level, 5% level. So we are going to go ahead and fill those in. So I'm taking before minus the after. So we have 10, 3, 16, a negative 11, a negative 1, 15, 27, 17, and 21. Our hypothesis statement, HO and HA are the mean differences are equal to 0, and we think level after the diet. So we think if we're taking before minus after, then we're thinking that the differences are going to be greater than 0. Okay. And it looks like there's a few that are negative, but the rest are positive. So we'll see. Step 2 is alpha is 0.05, and our test statistic here, the mean of the differences is 10.78 when you put those in decimals. And our standard deviation of the differences is 11.86 divided by the sample size of 9. Our critical t-value is t of 8 and 0.05. It's a one-tailed test. And so that critical value is 1.8595. And we are coming up with our test statistic as 2.726. Because it was a greater than test, we are drawing over here. And our critical value is here. And we do fall in the danger zone. So we are further than that. We're over here somewhere. Um, and so we can find our p-value as the probability of finding a t more extreme, so greater than our test statistic under these circumstances. And that would be pretty small. So it's 0.013. So our p-value compared to our alpha is less than for sure. So we do reject H0. So there is sufficient evidence to support claim that new diet lowers cholesterol. With example 2. So let's look at example 3. Example 3 says a college football coach was interested in whether the college's strength development class increased his players' maximum lift on the bench press. He asked for players to participate in a study. So they lifted prior to taking the class. This is what they could lift, and this is what they could lift after taking the class. And we are hoping that our after is bigger than the before. So we are doing a test of a greater than. We're going to be shading this way. So we're doing a test that's greater than. So we're going to take the after minus the before. So this is a positive difference, a positive difference, a negative difference, and a negative difference. Okay. So, so we are going to need to find the sample mean of the differences and the sample standard deviation. When you put those into Desmos, we get 21.25 and then 46.7 as a standard deviation. And so this becomes a test of a single mean, because we now have only one set of data, which is this data right here. And so we're testing the differences that are greater than 0. Our test statistic, when we put that in, we get 21.3 subtracting 0 over 46.7 divided by the square root of 4. Our test statistic is 0.9122. So it doesn't look very outrageous to me. So we'll see. Our critical T value is 2.353. So we're not in the danger zone. And the p-value, when we put that in, comes out to be 0.214. And that is greater than alpha of 0.05. So we do not reject H0. So there is not sufficient evidence to say that the class increases their max lift. So it does not say that because we do not have a sufficient evidence for that. So that was example 3. So example 4 in your course pack, you can go ahead and do that one, try that on your own. And then there's a little quiz that is just part of your notes, basically category, that will just test to see if you understand how we are going to work through these problems before you head to Alex. Reach out if you have questions and have a blessed day.